am Karthik Kumar Reddy, working as an assistant professor in Nalla Narasimha Reddy Education Society's group of institutions. In the Department of Civil Engineering, in Foundation Engineering subject, in Unit 2 Slope Stability. In this lecture, we actually have discussed about the number of methods of slope stability, analysis of slopes, and along with some examples. Now in this, we are going to determine the most critical slip surface. That is determination of most critical slip surface. The criteria for most critical slip surface used to find the minimum factor of safety. Now criteria for selecting the most critical surface is that the surface which actually gives the minimum factor of safety and which can be the potential failure surface. So there are trial and error approaches that are involving basically. It involves the location of the center of the rotation and the radius of the slip surface and distance of intercept of slip surface from the toe and minimum factor of safety issue. Generally it is done by if a slope is there with a perpendicular bisector from that within that a grid of centers are selected and among the grid of centers then we select innumerable number of circles with radius or that is minimum radius and maximum radius. When we have this grid of centers which are selected and located at the almost at the perpendicular bisector of the slope surface and each of the grid of center. When you analyze first number of slip surfaces, the one whichever is the center or grid of the center which gives the least factor of safety, that is actually treated as the minimum factor of safety. So if that grid, the selected grid is inadequate or inappropriate, then one needs to select the grid such a way that the minimum factor of safety is achieved. Here in the Fellenius in 1935 proposed empirical approach for the cohesive soils, particularly for undrained condition for phi is equal to 0, that is with the soil with Cu and that is with undrained equation and different slopes like one way 1:1, one vertical and 1 point horizontal or 1 vertical 0.58, 1:2 or 1:3 and 1:5 with alpha, that is the angle and psi. These are the cosine directions. Cosines with that for this beta is the slope inclination. That is beta is called as slope inclination. So draw a line through the converse of the slope at an angle alpha and SI as far in the table, and O1 will be the center of the rotation. So this is one of the conventional method. Another conventional method which was actually given by Jumkis case, that is possible location of centers for C dash and phi dash soil, wherein here when the center of the rotation of the critical circle is assumed to be lie at point PO1, PO1 and point P is at a distance h above the h below the toe, that is h, and 4.5 times the height towards from the toe of the slope. So when you draw the line wherever it is actually meets along the line, the one which check this analog is nothing but the different factor of safeties and the one which actually gives the least factor of safety and is called as the possible potential failure surface. So in this lecture we try to introduce how to find a critical failure surface through conventional methods as well as some numerical methods by using Fellenius method of slices and Jumkis method.